Action. Oh, hey Mr. Howell. So, for our physics video, we will be exploring the physics of New York City. Oh look, Dragon Ball Z. Anyways, not only can you find multiple loyal students in the city, oh, hey Emma. Hey, but you can also find multiple examples of physics. Let's go. You can also find many examples of physics in regular stores, like Barnes &
Centripetal force is also known as a center-seeking force that makes a body follow a curved path. Siobhan moves with a uniform speed along a circular path.
Run! Whoa, Lily, that was close.
It was.
Alright, so I think we should head downtown to find out what physics we can do down there. Let's go!
What Frances does in this video is overcome friction. By increasing her velocity, she can overcome any friction and go any distance or displacement.
Centripetal acceleration can be a bit difficult. I mean, look at this equation. So, I'm just going to let my friend Luckham handle this one and explain to you what it is.
In this video, you see Siobhan, Frances, and I on a merry-go-round. This is an example of centripetal force, which is also center-seeking. As seen before, all we do is go around a circular path, moving along in a uniform speed.
Okay, so we made it. We made it from downtown to from Chelsea Piers. Let's go. We snuck into the school, so we're gonna find out what other examples of physics in New York City we can find.
Or we can just go back to physics class. Let's go!
I am Superman! Just kidding! It's physics!
The normal force is the force that is acting perpendicular to the surface. In this video, Siobhan is applying the normal force to the bridge of the Pyramid Park.
Go. Parkour! Just kidding, I'll take the stairs.
Lily, what are you doing? We have a project to do.
This is the project. It is physics. Watch.
Swinging can be a great example of potential and kinetic energy. At this point, Lily has gained potential energy, and at her next point, you will see that she is slowly going back to kinetic energy.
In other words, energy is neither created nor destroyed. Rather, it is conserved. As the potential energy decreases, the kinetic energy increases, and vice versa.
Here you see the formula for work. As you can see, work is force times distance times the cosine of the angle. In the video that follows this, Siobhan will be demonstrating how that works. Work in this equation is directly related to the force and the cosine of the angle. But the force and the cosine are actually indirectly related, which means when the force goes up, the cosine of the angle goes down, and vice versa. Either way, the force and the cosine of the angle determine how far the table goes.
Hey, Mr. Howell, did you know that I lift in my spare time? But what I'm actually doing is work.
When I get on the skateboard in the next video, this will definitely prove Newton's second law, which is force equals the mass times acceleration. You can determine the force by calculating my mass times the acceleration that I go at when I'm on this rad skateboard. This skateboard is courtesy of my old friend Caroline McGinnis, who owns this very nice Land Yachts cruiser.
Who knew that Newton would be relevant today, even in skateboarding?
Displacement is what Luckham and I did. Displacement is we went from 86 all the way down to 14th and looped all the way back up. That means that we started in the same exact place that we did from the beginning. So our displacement is 0. Doesn't matter how long we went. Distance, however, is how long we went. So that's what matters. So Luckham and I, we traveled, let's see, from 86 down to 14th Street, that's about 2 miles, and 2 miles back up, that's 4 miles. That's how long we traveled. That's distance. Enjoy our adventures on the subway.
So we're starting at 86th Street. We're going to loop down to 14th Street and then come back up. And then our displacement will be 0. So we're on the 5 Express train going down to 14th Street. It's the Express, so we should be there pretty fast. Here on 14th Street, half our displacement is done. Now we need to go catch an uptown train to make our displacement 0.
Let's go!
While in the 14th Street subway corridors, I tested velocity to the maximum. I ran, and the longer I went, which is X, and increased my time, which is like the longer you go, the more velocity I gained. You can see right now. I think I hear the train coming. Run!
Well, we look pretty stupid, but we're going back up to 86th Street because, well, it's a physics project. And, you know, displacement, we're trying to get 0. And now we made it back uptown. We're on 86th Street again. We went to 14th Street. Great time.
Mr. Howell, we're going to test our knowledge. Let's go out and ask our fellow New Yorkers what they really know. Excuse me, miss. Do you know what physics is? No. You don't? Excuse me. Do you know what physics is?
No, sorry.
They need you, Mr. Howell. All right. More people. Hopefully we'll get some more. Hi. Do you know what physics is?
Yes, I do know what physics is.
What is it?
Well, it's a class I was supposed to take, but I didn't want to take because I took chemistry. Only people that took physics were going to be nurses and doctors.
Oh, cool. Well, there you have it, Mr. Howell. So we've tried men and women. Let's try and expand our resources. Excuse me, sir. Do you know what physics are? You don't?
No.
That's totally okay. Can you say hello to Mr. Howell? Hey.
Say hello,
Yeah?
Mr. Howell.
There you have it, Mr. Howell, your #1 fan. Anyways, not only can you find multiple Loyola students. Oh, hey Emma. Hey. But you can also find. Do it. Open the grove. And it's Brian.
Don't curse.
Sorry.
All right, I'm done. I give up. I don't want it. I don't want to die. Stop it.